So this video will show you how to do the quantitative plating experiment. For this you need a milk sample. So here I have the raw milk sample, and we have 3 bottles with 99 milliliters of water. So these are what we will be using to make the dilution series. And for each milk sample we will be plating 5 dilutions. So we have 5 plates. These are empty plates, and we have labeled them with the dilution and the milk sample. This is for the raw milk. So for this we need to measure out 1 milliliter of milk. So for that we will be using these sterile glass pipettes. They usually come in these cylinders. These are sterilized, so when you handle them you have to be very careful. So open the cylinder and take out the pipette, and since these are sterile, you should not touch the bottom part of the pipette. With this pipette you can measure 1 milliliter by drawing the liquid up to 0, and you can also measure 0.1 by drawing the liquid up to 0.9. So this is the pipette 8. So we can, this wheel, by turning this wheel we can draw the liquid up, and by pressing this button we can release. So I'm going to measure 1 milliliter of the milk and transfer it into the bottle labeled as 10 to the power negative 2. This bottle has 99 milliliters of water, so we are going to dilute the milk by 100 times. Of milk by drawing it up until it's at the 0 level, and I'm going to transfer this into this bottle. And the used pipettes, we usually discard them into a bleach container. So now, to homogenize the solution, I'm going to mix it. So when we make the dilution series, when we measure 1 milliliter from the milk, and then when we go down to dilution series, we always change the pipette. So for the next one, I'm going to use a new pipette. Now I'm going to measure 1 milliliter from the 10 to the power negative 2 dilution and transfer it into another 99 milliliters of water, and this will give the 10 to the power negative 4 dilution. So again we are diluting this 10 to the power negative 2 solution 100 times. Another 1 milliliter. Discard the pipette. Again, mix the solution well to have a homogeneous solution. And the next dilution, we use a new pipette again. Again, we are diluting the 10 to the power negative 4 100 times by taking 1 milliliter from it and mixing it with another 99 milliliters of water. So this bottle is labeled as 10 to the power negative 6. So we are diluting the 10 to the power negative 4 solution again 100 times. And we discard this one. So now we have 10 to the power negative 2, 4 and 6 dilutions. Now we have have the three dilutions, so we are ready to plate them. So we need 10 to the power negative 7, 6, 5, 4, and 3. So we have 10 to the power negative 6, 4, and 2. So how do we get this negative 7, 5, and 3? So another way of making a dilution is taking a fraction of a milliliter instead of 1 milliliter. So here we will be taking 1/10 of a milliliter, which is equal to diluting it 10 times. So by taking 1/10 of the 10 to the power negative 6 dilution, we can get 10 to the power negative 7. So we'll measure 0.1 milliliters from the negative 6 dilution, and that's what we will be plating. So like I said before, we can use the same pipette to measure 0.1 milliliters and the 1 milliliter. So this is a different kind of plating. So as you see, there's no agar in this. It's just empty plates. So we call this method a pour plate method. So we first measure our samples into the plate, and then we pour molten agar into the plate and mix it with our sample. So here we'll be using agar that is around 55 Celsius. That is enough to keep the agar melted, but it's not hot, too hot, so that our sample, the bacteria in our sample, will die. So it's just cool enough to keep it, keep the temperature cool enough for the bacteria not to die, but still it's warm enough to keep the agar melted. So first, what we will do is measure the appropriate milliliters volumes into our plate. So first, let's take a new pipette. So when you're using a dilution series, if you first measure the lowest dilution, you can use the same pipette when you go to the higher dilutions. This way we won't be introducing too much extra cells into our samples. So first we will measure 0.1 milliliters from the negative 6 dilution. So 0.1 is up to the 0.9 mark of the pipette, and then we'll put this into the center of our plate. Right. So we can use the same pipette and measure 1 milliliter from the 10 to the power negative 6. This is equal to 10 to the power negative 6. We're taking 1 milliliter and so we're not changing the pipette. It doesn't matter because we started from the lower dilution. Therefore, we can use the same pipette because this is a much higher dilution, so we won't be, the amount of cells that will be introduced is negligible. It's a very small amount. So we will measure 0.1 again, because this is the 10 to the power negative 4. By taking 0.1 milliliters only, we are getting a 10 times dilution that gives us 10 to the power negative 5. And put that in the center. And to get the 10 to the power negative 4, we will take 1 milliliter. From the negative 2, again we are only taking 0.1. So again 10 times dilution, giving us the 10 to the power negative 2. Alright.
So in this video, I'll demonstrate pouring agar into a pour plate and swirling the pour plate. So you're going to remove the molten agar from the water bath. You can see that it is liquid and there's no chunks in it. You want to make sure there's no chunks, because if there are chunks, then it does make it a little more difficult and you don't get as good of a quantitative result. So after wiping off the water to prevent dripping onto your pour plate at all and risking contamination, you will unscrew the top and pour the molten agar into the pour plate. Once you have poured the agar into the pour plate, you are going to swirl the agar 5 times counterclockwise, and then another 5 times counterclockwise. It is very important to do this, otherwise you're not going to thoroughly homogenize the sample that you have put into the agar, and you will not get as good of results.